All right, friends, so we're talking about exponential functions today. And let's just remind ourselves that we're looking at some f of t is equal to a times b to the t. And we're going to try to make a formula to make that work. So I think we can probably construct a formula. Let's pick 2 points in space. How about 3, 5? And let's go through something over here as well. How about 13, 11? Just to have 2 points to work with. And what I'm going to do is I'm going to employ my relationship here. And I don't think this is the way you're going to do it every time, but I just wanted you to see where everything comes from. That I can have one equation, 11 is equal to a times b raised to the 13. And I can have another relationship, 5 is equal to a times b to the 3rd. And so my dream here is how do I relate these two together? And I'm going to divide one by the other. So if I divided this by 5 and this over a times b to the 3rd power, certainly the a's would murder and I would be left with 11/5. And the b's, we're going to subtract the exponents. We're going to have b to the 13 minus 3, or b to the 1/10. How do I get rid of, oh my goodness, not b to the 1/10, b to the 10th. Now, how do I get rid of this 10? I'm going to raise both sides to the 1/10 power, so I'm going to have 11/5 to the 1/10 power equals to b, and we're out, yeah? Except for the fact that I need to figure out how to get my a value, and one way to do that would be to put this b into either of these equations. I'm going to use this point right here. So we can have 5 is equal to a 11 over 5 to the 1/10, and then all of that gets cubed. Now I can clean this up. This is equal to 5a 11 over 5 to the 3/10 power, and I can divide by that so that 5 over 11 over 5 to the 3/10 power equals a. And I know some of you probably want to express that with a negative exponent, and you can do that. That's between you and your God. Now, I want to point out a couple things here. That if this I treated as y2 and x2 and x1 and y1, I can make a formula for b. And I think that sometimes this is better to do. That here I have y2 over x2 raised to the 1 over y2 over y1 raised to the 1 over x2 minus x1. And so I think this formula is very fast to arrive at, and we did it one time, and for the most part, I'm going to run with this b value. The other thing that I want to talk about is, if I give you the a value, it's very easy to make the equation. Suppose I gave you the point, say, 0, 3, and I let you know that b was equal to 1.7. Well, we know that the formula will just be y is equal to 3, our initial value, times 1.7 to the t. And we're out, right? Not a great stretch of the imagination. But now, what if instead of going through the point 0, 3, I wanted to go through the point, say, 5, 3? And we're going to have the exact same exponential. It's just been shifted over here. And so we know that making the right shift, we're going to not use just t as my argument. We're going to have t minus 5 to make a right shift of 5 units. And so, sure, here my original equation was 3 times 1.7 raised to the t, but this equation right there is going to be y is equal to 3 times 1.7 raised to the t minus 5. And one of the reasons I love this relationship so much is that I'm rarely going to be given an initial value. And so given a point, if I put 5 into my equation, here we'll have 5 minus 5. I'll have 1.7 raised to the 0. Murder will occur, and we'll be left with 3. We're going to do this one more time, and then we'll call it. So let's make some exponential function. And we'll have it go something like this. But unlike we did before, I'm going to give you this point, and we'll call that, how about 2, 7, and I'll give some other point, how about 9, 1. And so we can certainly say that our b value is equal to 1, and I'm always going to use the larger x as my second b value, or my second point, because I want to make sure that I have a positive exponent. You can have a negative, but it's just nicer to keep it this way. 1 over 7, that's y2 over y1, raised to the 1 over x2, 9 minus x1. And so turns out I have 1/7 raised to the 1/7 power. Okay, I didn't mean to do that, but so be it. Let's keep going. And if I gave us this point to make the equation with, it would be the point 0, 7. And if I was going to use that, and I'll just call this y is equal to 7, my growth factor, 1 over 7, raised to the 1/7, and then that would all be raised to the t. If I wanted to, I could clean that up. I could say that this is 7 times 1/7 raised to the t over 7. Yes, because our exponents, they multiply together. But that's not the equation that I want. I would want this one, but then I would shift it over 2 units to the right. And so if I was going to use this point to make the equation, I would think about if it started at 0, 7 and then got moved over. And so instead of t, we're going to write t minus 2. So we'll have y equals 7, 1/7 to the t minus 2 over 7. And so that means I took this exponential that I first made and made that right shift. Let's just check to see what happens. When I put the 2 in, 2 minus 2 will be 0, over 7, still 0, raised to the 1/7, 0, and we're left with 7 as well. You know, I could also test this point right here. When I plug 9 in, I better get 1 out. And so let's see what that happens. 9 minus 2 is going to be 7. 7 over 7 is 1. 1/7 raised to the first is 1/7. And then 7 times 1/7 gives me that 1 back. And we're great. I want us to be able to do this at any time. And while I don't really like writing this, I'm going to put it out there for us. It's like point slope form. And so we can say that y is equal to y naught times b raised to the x minus x naught. And so it's like point slope form. Maybe I could call this like point growth factor form. Now, I don't think that's in any textbooks. I'm not really in love with this idea, but it's a way for you to begin to get your head wrapped around it, because I despise finding an initial value when I'm given these other points. Let's see if we can do it one more time. Let's just make the exact same equation with our b value of 1/7 raised to the 1/7 power with this point right here. And so it's certainly going to be y. Our output is 1. You know, I normally wouldn't write that, but I want us to be very clear what's happening. Our growth factor is 1/7 raised to the 1/7 power, but I need to make that right shift of 9 units, and so I'll have t minus 9. And that right there, my friends, is a possible equation for this. Now, the one thing that we have to be concerned with, if I'm going to give these shifted versions here, they don't explicitly tell us what the initial value is. And so how on God's green earth can I get it? Oh, well, I can just put t equals 0 into this one. And so one possible way of describing the initial value would be 7 times 1/7 raised to the negative 2/7. Or if I put 0 in here, it's going to give me the exact same beast, 1/7 raised to the negative 9/7. So I think that needs to go down in order to make these things happen.